Okay, we're going to go to some graphing now, which is always fun. For your reference, this is in section 7.3 of your notes. I'm going to start with number 7. Now I see here that I'm supposed to graph a quadratic equation and a line. I'm going to start with the line because this is easier. I want to remind you that in our format y equals mx plus b, m represents the slope and b represents the y-intercept. And the y-intercept is where I'm going to start graphing. So I'm going to start this graph at -2. And I see my slope is also -2. That means rise over run. So this means I could put that over 1. My rise, meaning my up and down movement, I'm going to go down 2, right 1 for each of these. So down 2, right 1. I'm just going to keep that going for as long as I feel. But I'm going to also keep going in the other direction. So go 2, left 1, and just keep those points going. And I'm going to connect it. Cool. All right. So the part where I'm sure we need a refresher on would be graphing the quadratic. Well, this is in standard form. Remember that is y equals ax squared plus bx plus c. And if we want to get the vertex, which we definitely do, that's the most important point of a parabola, to find the x coordinate of the vertex, we're going to go opposite b over 2a. And then we're going to plug that into our equation to find the y coordinate. So for this equation, I see that a is equal to +2, b equals +8, and c equals 10. So to find the x coordinate of the vertex, I'm going to go opposite b. So because this is positive, I'm going to go -8 over 2 times a, -8 divided by 4, which is -2. So the x coordinate of my vertex is -2. And just keep that over there. So to find the y coordinate, I'm just going to plug it in to this equation up here. So that's going to be y equals 2 times -2 squared plus 8 times -2 plus 10. And I could solve that by hand, but this is why we have calculators, is to make our lives easier. So 2 times -2 squared plus 8 times -2 plus 10, +2. So this is my vertex. Is -2, +2. -2, +2. Cool. That means we already have a point of intersection. Well, now I'm going to graph it. I see that remember this a value is 2, and we're going to follow our 1, 3, 5 pattern, meaning 1a, 3a, 5a. That's our growth rate. So this is 1 times 2, which is 2. 3 times 2, which is 6. 5 times 2, which is 10. So this means I'm going to go from my vertex, I'm going to go over 1, up 2, up 2. From there, over 1, up 6. 1, 2, 3, 4, 5, 6. That's as far as the graph will let us go. And I do the same thing in the other direction. Over 1, up 2, 1, 1, 2, 3, 4, 5, 6. Okay. So the solutions are any points of intersection. So I got one there, and I got one there, which means my solutions to the system are -3, +4, and -2, positive 2. And there's that one. In the same vein, let's just go tackle number 9. What's different here, I'm going to zoom in a little bit for us. Okay, what's different is that this is not a parabola. This is a circle. And you're going to get more to circle stuff in the questions below. Well, let's remind ourselves the standard form of a circle is x minus h squared plus y minus k squared equals r squared, where the coordinate hk is the center and r is the radius. So for this question, I'm just looking in the parentheses to see what the center is. Because there's nothing in parentheses here, I know that my center would be 0, and it's minus 3, but the equation was minus k, so that means positive 3 is going to be my center. So 0, 3 is the center. Now you see that r squared is the one on the end, so if r squared is equal to 4, I'm going to need to take the square root to find out what r is. So my radius is 2. So from the center, I'm going to go 2 in each direction. 2, 2. And once again, I want to remind you all that this is a safe space where we do not judge each other based on how our circles look. But if I do say so, that was a pretty good circle. Okay, now I'm going to draw the line. Remember, here's our slope. Here's our y-intercept. So I'm going to start at positive 3, up 2 over 1, 2 over 1, down 2 over 1. Here's the thing. Based on how I drew my circle, it looks like I have some really pretty points of intersection. Problem is they're not going to be that pretty for everybody. And so we're just going to approximate our answers here because they're not exact, meaning they didn't intersect at one of these points that I drew on the circle. But approximately looks like our solutions would be here and here. Negative 1, positive 1, and positive 1, positive 5. On the test, you would have pretty intersections. Oh,